Hello, welcome to GeoAI tutorial number 5. In this video, I'm going to show you how to do building extraction using deep learning and GeoAI. And this is probably the most exciting video I've ever created because it's going to empower so many downstream applications. And it's just the beginning, so stay tuned for many more videos to come, how to use GeoAI for doing object detection, lane cover classification, all kind of things that you can do using GeoAI. And so in the last couple of videos, I've shown how to install the GeoAI package, how to download the data, how to checking the metadata information, also how to create image chips for training deep learning models. In this video, we're just going to use the pre-trained model. So just with a couple lines of code, you can extract buildings from high-resolution aerial imagery without complicated coding. And I'm going to show you how to do that. Before you get into details, you need to visit the website to download the notebook example to your computer, or you can run it using Google Colab. So go to the geoai.gshub.org and then examples, click building footprint USA. The link is also in the video description below. You can scroll down, you can actually visualize the map interactively. So for example, this is the final result, and this is the building that we extracted using the model just with couple lines code. And you can zoom in, you can zoom out. The color represents the confidence. Upper right corner here, there's a color bar showing you the confidence level ranging from 0.5 to 0.9. So the higher the confidence, basically the higher the likely of that it's a building is a correct detection. Smaller values, basically the blue color represents lower confidence. That means the building might not be buildings. You will see there are some missing buildings in here. We will need to adjust the parameters to get better result, but this is just using the default settings, and it's already did a pretty decent job here. This is the original result. You can also regularize the buildings. So the second example here, this will be the regularize. So if you zoom in here, zoom in all the rectangles. Again, just one line of code, you can rectangularize the building so you can create better building shape. If most of the buildings are rectangular, this is perfect. Right? And again, I'm going to show you how to do it very easily. In order to follow this tutorial, you can use Google Colab. So upper right corner here, you can just right click and then open this one. After that, you need to turn on the GPU. So go to the runtime and then click change runtime type here. Then switch this one to T4 GPU. Click save. Then you should be good to go. So you're going to switch to the GPU and then you want to uncomment this one, Control/. Click this button. Then you will be able to install the package. Then you can run step by step, just like what I'm going to show you in this video. Or you can download the notebook to your computer. So upper right corner here, there's a download button on the page. So if you click, then it should pop up and showing you how to download this one to your computer. So you just click OK, then you will download the notebook, but you need to install that one on your computer. So next, let me show you how to do that using Jupyter Lab. I have set it up on my local computer, and this is the notebook. So let me zoom in a little bit here. So the first step is to import the library. Just import GeoAI. And then we'll just run command enter, control enter. It's going to import the GeoAI Python package. After that, we want to download some sample data. So we have two sample data set, the original raster imagery from USDA net imagery. So it's a high resolution 60 centimeter imagery. Also, we have the building data. This one we don't really use. It's just if you want to do the comparison, you can. Once you have the file path, you can just download the data to your computer. And just GeoAI download file, you will download the file to your computer. After that, we can start creating the model. And it's very simple, just one line of code, GeoAI building footprint extractor. And that's it. You don't need to provide anything else. By default, it's going to use the pre-trained model. So if you want to learn more details, where does it come from? It actually comes from the Esri building footprint extraction models. So basically the pre-trained models. You can go to click the link to go to the web page. But if you want to use in GIS, you need to ArcGIS, you need to have the license to run the model. Right now, we're using just free open source, so you don't need desktop GIS to do that. Okay, so just run this line. Just click run. it should be able to download the model. If this is the first time that you're running the model, it's going to go to Hugging Face to download the model to your computer. Once it's done, we have this model set up. Then you can start doing building extraction. So there are two options. Here you can do building extraction. The first way is to extract the building is a raster mask, and then you convert the raster to vector. Or you can just use the shortcut here. The second way, just directly extract buildings as vector data. So either way is fine, but I'm going to show you the first way is to extract the save mask as GeoTIFF, passing the URL, the file path. So this is the name image that we're using, and you're going to save this one as output mask. You can set a confidence threshold. The confidence means the higher the value going to range from 0 to 1. The higher the value, the more confident, the smaller number of buildings you're going to detect. The smaller the confidence threshold, that means you're going to detect more buildings, but you might end up with a lot of false positive. So you need to adjust the parameters. There's also a mask threshold here. I'm just going to run this one and see how it goes. Very quick, just one to 2 seconds. Now we're done. It's also going to show you the basic information. The confidence level, the chip size, 512 by 512, and also the threshold. So it's going to basically subdivide the imagery into smaller tiles, because the imagery is, I don't show the original sizing here, but basically it's subdivided into 3 rows and 5 columns of chips. Then the model is going to basically loop through the chips. So it depends on how the chip size. So by default, we're using, I think the chip size is 4. The batch size, so basically each time you are putting 4 image chips into the model to do inference. And 3 by 5, basically we have 15, right? So 15 divided by 4, so roughly equal to 4. So this is why we have 4 batches, right? So basically from the first row, second row, third, we only have 3 rows. So 4 images in the first row, and then the other 4 images. So 4 by 4 is a batch. Then you can run the inferencing, and then you get the result. The nice thing is the output is just a mosaic raster, so automatically convert mosaic name as a single raster, so it's not by chip anymore. And you can also convert it to vector. So all you need is just run this function, mask to vector. So we're going to utilize the output from the previous step, and we're going to generate output called mask GeoJSON. You can also specify the tolerance, basically how to simplify the vector boundary, because if you don't simplify, you're going to end up with lots of pixelated and zigzag. Sometimes it doesn't look very good, especially some of the buildings, the outline, we need to be rectangularized. So this is the first way of extracting the building footprint. So essentially with just 3 lines of code, we are done. But the recommended way would be to using this one, using the process function, process raster. So all you need just, because once you have to extract some model, call this process raster function, passing the imagery. So whatever imagery on your local computer, it can be GeoTIFF, it can be a small file, it can be a large file, it doesn't matter. And it's going to basically retrieve the imagery and then subdivide into pieces. Then you could run through the model. You can see, you can adjust some of these parameters in here. If you have a larger GPU, you can increase this number. If you have a smaller GPU, then 4 probably should be fine, but it's going to be a little bit slower. Also, you can adjust the parameters, for example, the confidence threshold, like what I just mentioned earlier. Let me run this one first. So you can see very quick, 4 batches, and just one couple seconds. Also, one thing I want to mention here is the small building area, 100. That means any building smaller than 100 pixels is going to be removed, because you might if a smaller number, you will end up with a lot of smaller objects, so you might end up with a lot of a false positive. You need to play with this threshold. So if most of buildings are large buildings, you might want to increase the number. But if you're detecting smaller buildings, then you want to decrease the number. Also, the simplified tolerance is after you finish the building extraction, you want to simplify the outlines. Once we get the building footprint, the next step, you can apply some additional regularization, because most of the buildings might be rectangular, so the shape I will show you the comparison, but you just run this one. I also set the minimum size 100 pixels, angle, and also rectangularity. These are some of the parameters. If you want to see more information, press Shift tab on your keyboard, and then you should be able to see the parameters. Shift tab. You should be able to see all the descriptions about the functions. So I'm going to run this one. You see, very quick. And now we have the result. So we can actually preview the result first. Let's look at the original building output from the model. You will see this confidence column here. The confidence basically represents how confident is the model for detecting that particular building. And most of the value is going to range from 0 to 1. So the higher the better, the more confident. And because we set a threshold of 0.5, that means all the buildings going to have a threshold higher than 0.5, less than 1. And even if the result is not very good, you are missing a lot of buildings, then you decrease the confidence threshold. All right, so now let's visualize the result. We're going to call the function view vector interactive. And so this is the original building extraction result from this process function from here, from the second option 2. Now let's look at the result. Okay, so this is the map. We can also specify the tile to satellite. That means we're going to use the Google satellite. Upper right corner here, you should see the color bar. The color bar represents the confidence level. And so if you look at the map, let's zoom in a little bit, full screen, hover your mouse, you will be able to see the confidence level here, right? And the blue color represents low confidence. Yellow color represents high confidence level. And if you see on the right here, pretty good. Most of the buildings are being detected. There might be some missing buildings. It's not going to be perfect. You see one of this in here. Also, you might see some offset that the building outline doesn't align perfectly very well with the base map. That's normal because this is the Google base map. We don't use this one for doing the detection. We're using the USDNet imagery. I will show you in the next example, but at least right now you can can see the result. There are also some artifacts here, like some of the building that are being detected like twice. We need to do some post-processing, but as you can see, very low efforts, and play with the parameters. If you find some optimal parameters works best for this area, leave your comments down below. I will be happy to adjust the parameters. But right now we're just using all the default parameters in the GeoAI package. So this is the original output that has been simplified a little bit, but you see it's not perfect, especially for polygon like this, right? You're gonna have some of this zigzag, and this is why we need to do some regularization. What you can do is to call this function, or the second one, let's look at the original imagery. So we're gonna overlay this building output on the original imagery, basically the one that we downloaded from Hugging Face. Okay, so this is just a small area. This is the original imagery that we pass into the model to the detection. You should be able to see the building align pretty well with the raster dataset. And still, we have the confidence. If the confidence value is the same as the previous example that I just show you, but you made me identify some missing buildings. It's fine. You just again need to adjust the parameters. Right now, it's default. Just a couple seconds, then you get the buildings. How cool is that? All right. So next example, we're going to do visualize the regularization. So we're also going to call this vector interactive function. Now we can compare these two. Zoom in. These building footprint right now are perfect because in this area, most of the buildings are horizontal and also vertical. So it's rectangular shape, and it's so much better that we can rectangularize the building footprint. If you compare this one to the previous one, it's going to be quite dramatic. So look at this, right? So these are some of the buildings. It looks the shape. If you zoom in, you're going to see this zigzag. It's normal because it's converted from raster, and it's going to have something like this. So if you need some simple method to rectangularize, then you just use the rectangular building footprint. So extract the regularized buildings, then you will get the result regularized. So this is how just you can regularize the building, just one line of code. We can also visualize the data on a static map. So just extract the visualized result. You will basically generate a PNG so that if you don't need to see it on the interactive map. So this will show you the result, right? So just a small thumbnail of the building's extraction result overlay on top of the original imagery. It actually also generated a complete one. So if you zoom in, open the table of content here, if you click this one, NAIP underscore buildings, this one actually is the entire imagery, contains all of them. And this is a much larger one. So if you zoom in here, right, look at overall in total, we have 681 buildings. It's just draped on top of the entire raster. So if you just want the small, take a preview, then this might be useful for you. And similarly, we can overlay the imagery, the regularized building footprint on the imagery as well. And so this is what it looks like. Again, this is just showing a small sample area, but we should have this NAIP underscore buildings regularized. So if you click this one, double click, it should open that one as well on the right. So this would be just the simplified result. The regularization is quite complicated. There are different methods for doing building regularization. I will show you in the next video, and you can compare the result, which one to use for different area. This is actually quite a challenging issue. There's not a single method that works best in all area. It depends on the shape, depends on orientation, depends on variety of parameters, and you might need to use a combination of regularization to get building footprint. All right, so this is how you can run the algorithm and then simply extract the buildings. You might notice here I only using a small imagery, so this is only 12 megabyte, but you're welcome to apply to a large imagery. I'm going to show you. I actually have a large imagery on my computer, and it's also the imagery that I host on Hugging Face. If you want, you can download the data. If you have enough GPU, you can run this one. It should not, if you have 6 or 8 gigabyte GPU, it should work. So this is the 358 megabyte of raster data set, and I can show you here. I simply just, let me clear all the outputs and then show you from the beginning. So I'm going to switch to using this raster data set here. All right, so I'm going to uncomment these two lines of code. So this is the imagery that I have here on my computer, and look at this, it's this file. So this is the same one that I show you on Hugging Face. So it's a pretty decent file size, 350 megabyte. I also have this one on the internet. So basically what we are going to do is to use this local raster for doing building extraction. But when we are visualizing the building footprint, we are going to pull the imagery from Hugging Face, so we can use that as a base map. All we need to do, just import the library, and then that's it. Then we can see how it works. So import GeoAI, then just go to this line of code here. I'm trying to apply it to this last raster data set. So just run this one and then click here. Oops, extractor. So we need to initialize the model. So let's run this one here, initialize, and then run this one. Take a look. So this one is a much larger size, but it's the chip size is 512 by 512, and we end up with 107 batches. So the base size is 4, so that means it's 107 multiplied by 4, and it's still pretty quick, right? So when you're running the model, it only takes a couple seconds, but after that you need to basically merge all the types together as a single vector data set, and then you need to do some simplification. So this one might take some time. It's a little bit longer actually than the referencing, because that one doesn't really utilize all the GPU. It need to utilize the CPU, but depends on how complicated the building. Sometimes the simplification process might take a little bit longer. So this is how you can run that on a large data set. The nice thing about this is we provide a single raster, a big raster, not image type. So you don't have to worry about how do I subdivide the images into smaller pieces. Under the hood, the package takes care of that for you. So you just input a large raster and then you output a large vector. And take a look. So now we have all the building results. We have 2,458 buildings extracted for this imagery. You can also do the rectangularize if you want. So this one should be pretty quick. It's done less than 1 second. Now we can visualize the results. So I'm going to just simply run GeoHead Similarly, we have this confidence column showing you the confidence level of the building extraction. Now, let's look at the result. So view vector interactive, then use the confidence level and see. So earlier we have just this area, but now we have a much larger imagery that cover all area. And if you zoom in quite nicely, like if the buildings are rectangularized, it's pretty nice. And also some of these buildings, when you zoom way in, you might see some zigzag, and this is normal because it's simplified from the raster output. So it's going to look something like this. We can further simplify the building output if needed. Again, I'll show you in the next video how to do regularization. For this video, we're just going to use this one. And similarly, we can show the imagery, the building footprint on the original imagery, right? So this imagery right now is pulling from Hugging Face directly and then use T-tiler to render the tile. So this is the imagery that we feed into the model to do building extraction. And the model itself is going to subdivide the images into smaller tiles. And then so each time it's going to feed four, the base size is 4. So 4 images into the model to do inferencing. So we're going to go from basically row by row and then until you finish all of them. You can look at in the entire area. So this is the imagery, the building footprint result overlay on top of the original raster dataset. So the outline, the building here should be aligned. They should align pretty well, right? So you look at all the buildings, and there some of these are not detected. It's normal. Again, we need to fine tune the model, or you can adjust the parameters to get better result. But this is like not much effort, just using a pre-trained model and just applied it and just take a couple seconds, you get all the buildings. How cool is that? You can certainly train your own model. It's going to take a lot more time. So evaluate the result. If it's not good, adjust the parameters. If it's really bad, then we can training our own models. Again, I will cover that in another video. All right, so besides the original one, we also do the regularize. So this would be the regularized version of the buildings. So zoom in, now we have all the building footprints in rectangular shape. And this works very well in this area because most of the buildings are regularized. Again, we also have the confidence level. So if some of the buildings are not very confident, then you might be able to exclude it. So for example, this one has a small tiny portion here. It's only 6.65, so it's not very high. 0.63, this one looks right. And some of the buildings, if the shape looks like not really horizontal or vertical, it might not be rectangularized. So because otherwise the shape is going to look very, very different. Overall, this looks pretty nice. Okay, it's a decent size imagery, and we have all the buildings detected using GeoAI, just couple lines code. The output is a single GeoJSON, not smaller pieces. So all the heavy lifting has been done for you. So you don't have to worry about how big is the raster. You can feed in any raster imagery into the model. It will be able to do that for you. Lastly is whether or not you want to visualize the result on a static imagery. This is a pretty big one, so I don't want to run this too. It's going to take some time. And also the output raster will be pretty big. So if you're working on a large area, you might want to just visualize the result interactively on a large map. If you work on a small area, then it's okay to overlay the imagery on a static imagery. And again, just take some time, navigate through, see how it performs. At least it's so much better than doing pixel-based classification. You are never going to really get this result. And with the pre-trained model and also GeoAI, it's just so easy. So anyone can do it. Just you open the browser and then using Google Colab, or you can run it on a local computer if you have some GPU. And it's so cool. You can run this at scale. You can run it at the county level. If you have all the images, you just look through them and then just generate the result easily. Then you can start doing the evaluation. So if you find optimal parameters that works very well in this area, feel free to leave the comments down below. I'm happy to adjust the parameters. I don't have time to do all the testing yet. So my goal is to build this, the package, and then add these functionalities. So it's going to empower you to do building extraction, for example, tree detection, airplane, ships, all kind of information. And also we can do land cover classification using high resolution imagery. We covered it in in a future video. There are a lot more videos to come, so stay tuned for more tutorials. I also welcome your contribution to the package. If you know how to do coding, you are welcome to go to the package and then look at the source code and anything help. Okay, so that's all this video. I'm very excited about the development of the package and also the feature tutorial. I will see you in the next one. Take care. Bye bye.